Hello, in this episode, we'll explore MNIST datasets of handwritten numbers. What is MNIST database? This is a database of handwritten digits like here. It's a modified National Institute of Standards and Technology database, and it's the handwritings from high school students and employees of the US Census Bureau. The reason why I discuss it is because often it's used as a benchmark data to test performance of machine learning, deep learning algorithms. It has 60,000 training sets and 10,000 examples of test set. Okay? And it was originally from Jan LeCun website, cleaned up, but there are CSV format websites in Kaggle and somewhere else. And how it looks like is that, for example, the training data, the 60,000 by 28 by 28. And the reason is because it has 28 pixels on the rows and columns, which creates a 2D panel image. Each pixel ranges from 0 to 255, depending on the darkness of where something is written, where something is blank. Oftentimes, people flatten this, meaning the 60,000 each samples, you multiply the 28 by 28, it's 784 pixels. You just line them up in a single row to feed it into neural network. So your neural network will have 784 input nodes, that is. Okay? So like 700 is for input nodes coming from the input data, network training, and do a classification whether it's a 0 through 9. So let's see how it works, MNIST data. The data comes from, again, some of these websites. We'll be using here the pjready.com's data and MNIST CSV file. Okay. Since it's a larger data, I will upload it on Google Drive and read it from there. So it takes maybe 20 seconds, so I'm done. And then the training data here, for example, the 60,000 samples. So how does it look like? It has 60,000 samples, and the pjready, the CSV file, kindly already flattened it for us. So the row, there are 785 rows. Why? Because the first one indicates what handwritten digit it is. So it's a 5. And then the rest of the 784 will indicate the pixel values. Okay, you can also store the test data, of course, and check the test and train data, the test data that is, isn't it? Test data. So split the label and image. So Xtrain is training data, only the pixel images. So you have 784, and then the label is here. It's the first column. Same with the test data. You get the images, the pixel images, and the labels. Okay? You want to convert them to NumPy to use it in many places. And also you want to scale it. In this case, I don't need a mean or something. I know that the value range, the pixel value ranges from 0 to 255. Neural network doesn't like too large numbers. It's harder to train. So we divide it by 255 to range the pixel value from 0 to 1 in both train and test data. So for example, you can plot it. Let me just pick one image, like the first, and let me just take the first one in the test data, index 0. So the first row of the image, X test, and corresponding label, let's see. Okay, and I can blow it up to 255 to make the images better. So 7, the first row of the test data was actually 7, and I'm picking up the 784 columns. And the 2D image, I have to reshape it to 28 by 28 panel. And then I can use the image show in the pyplot matplotlib. I'm just going to use the grayscale grays so I can shoot it. I can use Keras provided MNIST data to upload it. It's much simpler. It's such a frequent benchmark that Keras already has it in the package, so you can just read it from there. So if you have TensorFlow Keras dataset and import the MNIST. The MNIST load data will just get you the data right here. And it's a 28 by 28, 60,000, for example, the training data, it comes in a 28 by 28 panel. So you need to flatten it, just beware of it. So you can flatten the image in the test data. Again, it was a 7, so you can plot it. How do I convert, flatten it? Again, divided by 255, and I'm reshaping it. So the training data, I'm reshaping it to 60,000 by 28 by 28. I'm reshaping it to 60,784 columns, and then scaling it at one shot here. Okay, I can save it on Google Drive if I want to. All this. So basically, the summary in the future. When I benchmark MNIST data for my algorithm, I basically just import these libraries and call Keras MNIST data and just flatten to 784 columns, like rather than 28 by 28 to the panel, and this divided by 255 to range the pixel value from 0 to 1, not 0 to 255. Okay. Okay, so you can just do this. Okay. All right. And this is basically a simple exploration of the MNIST data to prepare for future benchmark when you need to use this data set. Thank you for watching this episode.